Hi friends, this is Anusha back to you with a new video. Acids produce ions in only in aqueous solution. So let us do this experiment. Aqueous solution is nothing but wet one, watery solution you can say. Now for that you take one test tube, add NaCl to this plus H2SO4, sulfuric acid, H plus means H first, H plus ions will give out acid. Okay, H first acid, first H if it is there it is acid, first if it is H is there it is acid, plus NaCl salt. Now NaCl plus H2SO4 will gives what? Will gives what? HCl plus Na2SO4. Now balanced. No. 2 now balanced. So HCl gas will come out. HCl gas will come out. What will come out? Gas will come out. HCl will come out. Now we want to test what? See, take one big. In that you test once with wet, first with dry litmus paper you test, blue litmus paper, dry blue litmus paper, this is blue color, dry blue litmus paper you test, dry. It does not change into, if you know, when blue litmus paper, dry litmus paper, when blue litmus paper is put it in the when you put to the HCl, it should turn into red, but it does not turn. But in another one, in the same experiment I am showing you. Now you take, here only you take, so that you will not have confusion. Here you take wet litmus paper. Then this will change into red color. Then it will change into red color. So from this, HCl plus H2O. HCl plus H2O will give what? H plus ions will come out from this. HCl is nothing but now H plus Cl minus. H plus Cl minus. This H plus dissociation of this will go and combine with this to form H3O plus. Then this Cl minus will come out. In the presence of water, it will split into H3O plus. Hydroxide with the base, if you see base like NaOH, in that also it is going to split into Na plus H2O. It is going to split into what? It is going to split Na plus OH minus, isn't it? This negative ion is going to combine with water. The negative ion is going to combine with water. In the presence of water, need not to add here water for the base. In the presence of water, what it splits into? Na plus OH minus KOH, H2O, K plus OH minus, and negative ion is going to get, hydroxide ion is going to get splitted off here. There positive. So what if simply you can say OH is there, then it will be OH minus negative ion, right? For the last, if it is there OH, then it will be base. From the starting it is there HCl, H2SO4, HNO3. Starting it is there, it is acid. Later NaOH, KOH, these all are bases. Exception is there for this acid, CH3, COH. Exemption, it is a weak acid. Isn't it? Like this, you need to do it. Next. When you are doing experiments, you need to, one more point you need to remember in this is, if the room is wet, if the atmosphere is humid, then if you add for the If you take dry litmus paper also, due to the humidity, the HCl gas, the HCl gas passed maybe turn this blue into red. So in that case it will be a exemption. In that case it will be a exemption. And so if H plus ions are completely splitted out, then it is strong acid. When it does not split completely, it is what? It is a weak acid. And next, we'll go with what? See. When you do experiments with acid or a base, when you do experiment with acid or a base, so first you are not supposed to add, see, if this is, in this HCl is there. What is that? HCl. It is strong acid. It will tear your skin also. So to that HCl acid, to make it to dilute. What do you mean by dilute and concentration? Dilute. If you add water to it, if you reduce the, if you add water to it, if you reduce the concentration of it, then it is said to be dilute. HCl, dilute means to pour water in that. It becomes dilute. Concentrate. The solution as it is, you can say. In that you are not supposed to add any water. In simple language, if you want to tell, you not to add any water. See, if curd is there, it is a concentrate one. If you add water to it, it becomes what? Buttermilk. It's a dilute one. Dal is a concentrated. If you add water to it, it becomes dilute. In the same way. So while you are adding to the HCl, if you pour water into it, it splits into H plus ions, Water if you add, immediately it will break down. It will split out and break down, split it out. And a huge damage may happen. So, you are not supposed to add water to the acid. Water to the acid you are not supposed to add. It will be a big danger. Then what you need to do? Take water. By constant stirring, you add HCl to this. By constant stirring, slowly you are supposed to add HCl to that. Otherwise, it will damage your equipment and you also sometimes. H2, SO4 also. Slowly you are supposed to add stirring. You need to add. Why? So when you add acid or a base, then what happens to the water? It gets diluted. Then it will get in a big water. This H3O plus ions are going to get splitted off. They are going to split it off. They are going to distribute it so that it becomes dilute. It becomes, I hope you understood the point, dilute. So what? During this experiment, it is an exothermic reaction. We saw, isn't it, exothermic reaction? It gives you a, when you add water to the acid, it is exothermic and it produces a large amount of heat. Sometimes it splashes out and damages equipments also. So, before you add water to it, you are not supposed to add water to the acid. You are supposed to add acid to the water slowly by stirring so that this becomes dilute. Means what? In a large area. See, I add 5 tablespoons of sugar in 100 ml of water. In 100 ml of water, suppose. Then what it becomes? Not 100 ml, okay, 10 tablespoons I'll take. 10 tablespoons in 100 ml of water. Okay, it will be somewhat thick sugar, isn't it? If I add to this sugar more 100 ml of water, then it becomes what? Dilute. Means in a large volume, in a large water, you are adding only a small, in a small quantity of sugar. Then it becomes dilute. In this way, the same, it becomes from concentrated to dilute. Here we are going to learn about another indicator. You know, litmus papers are there which change their colors when they are put in acid or a base. Another scale is there which is very sensitive than litmus papers and all indicators. These scale is made up of different dyes. Different dyes it is made up of, and it plays very important role in calculating what? H plus ion, hydrogen ion. It indicates the concentration of, important point, concentration of H plus ions. It will give you what? Concentration of H plus ions. You know, in the, what happens, see here, in the acid, H plus ions. In the base, OH minus ions. In this pH scale will tell hydrogen concentration or hydrogen concentration. It will tell you the hydrogen concentration. It is called universal indicator. pH is nothing but potence. What did it mean? Potence. In the German language, potence is nothing but power. So by using different indicators and all, it's a better indicator than all, you can say. It's a universal indicator. The universal indicator is going to be there in this way. See, on the scale from 0 to 14 the numbers are going to be there. 0 to 14 numbers are going to be there. Then see, if it is 1, red, pink, around 2 to 3 it's pink, 4 to 5 it's yellow, 5 to 6 almost it is yellow, at 7 it is green, and again 8 to 9 blue, 10 to 11 indigo, 12 to 13 it is violet color. What does these numbers indicate? These numbers I am going to tell once again. It is an indicator which is called as a pH scale indicator. pH, it is a universal indicator used for both acids and bases. It tells what? You know, the increase of hydrogen concentration in the solution. It will tell you the hydrogen concentration only, no, in acids and bases both, isn't it? Now acids and bases, both hydrogen atoms will be there. So hydrogen concentration it is going to tell. So from 1 to 14 the numbers will be there like this. And from 0, see, it be for the salts, if it is neutral, suppose it is a neutral solution, it also consists of hydrogen, isn't it? See, NaOH plus HCl gives rise to what? NaCl plus H2O. NaCl plus H2O. NaCl plus H2O means what? Base OH, H, both will combine. OH minus plus H plus will combine to form what? H2O. Then it becomes what? These two combines and get neutralizes and forms salt plus water. See, it also consists of hydrogen concentration, isn't it? So what happens? This is neutralization reaction. This takes place in the neutralization reaction. OH minus H plus will go to H2O, and these will form as a salt. These will form as a salt. Now see, it is a neutralization reaction. Now see, if it is see, 7 is neutral, green color it will be. It will be which color? Green color, neutral. It is color. All the salts, NaCl, KCl, all the salts you can say they are neutral. Okay, and when you go to the left side, there will be increase of acidic property. There will be indicate acidic property. Increase in acidic property means at 0 it is concentrated. At 1, yes, concentrated. Strong acids and later it becomes least CH3OH acetic acid will come near to it like this. Means it is a weak acid, isn't it? HCl at 0. Okay, and to avoid the negative numbers, always pH, H concentration is taken as less than 1 molar only. 1 mole only it is taken to avoid the negative logarithms. Then when you go this side, 8, it is a weak acid. I said no already. Increase in weak. See, here don't get confused. Here, strong acid. And this is weak. Here, it is what? What here? It is weak base. And here it is strong base. Means you remember in this way. 7 on the left and the right, weak. As this left side belongs to acids, weak acid. As the right side belongs to base, it's a weak base. It's a strong acid and a strong base. This is the how you need to represent the pH value. pH 7 neutral, left to that acids, and 0 indicates a strong acid, and from 1 it indicates weak acids, and then here weak base and strong. 14 gives you the strong base. The pH scale indicates what? Negative power to the 10. This is a pH value, whatever it may be. If you want 1 HCl, minus 1 you need to put here. You want for 10, minus 10 you are not supposed to put here. I have given one example, you see. See, pH value. The pH scale will give you the concentration of H plus ion. Concentration of H plus. So what? H plus is equal to 10 power minus pH. So pH value is nothing but, what you can take? pH log, applying log H plus. Log H minus log H plus. Minus log H plus. Now see, H plus is nothing but hydrogen concentration is given by mole per liter. For 1 liter, per liter, how many moles of H is there? That will give you the concentration of acid or a base. Then see H plus. So H plus is 10 power minus 10. Suppose if it is a minus 10. H plus, how much concentration is there? For the H plus, 10 power minus 10. What is the formula? pH is equal to minus 10 log H plus. Then substitute in this. Now it's what now? pH is equal to minus 10 log H plus. Then see, minus log 10 to the power of minus 10. Then that is equal to minus into minus 10 log 10. That is equal to 10 log 10. That is equal to what now? pH value is equal to 10. Then see here. pH. Now you see. Log 10 is equal to what now? 1, isn't it? So log 10 is equal to what now? 1. 10 into 1 will give you 10. 10 into 1 will give you 10. Here also. 7 into 1 will give you 7. Here also the same. See. H plus is 10 power minus 7. So 10 power minus 7, again you substitute here. Minus log 10 power 7. This minus 7 will come here, log 10. Log 10 is 1. So 7 into 1 is 7. 7 into 1 is 7. Now, did you understand this pH scale? I hope you all understood. See, when for the neutral, if pH is equal to 7, pH is equal to 7, pH is equal to 7, then it is neutral. It is neutral. If pH is less than 7, acid. When pH is greater than 7, it's a base. It's a base. So why this pH is important to us? Yes, the pH is important. It's a very, very important question it is. pH is very important in what? In human life, and in aqueous, in human life, tooth decay, and in soil also pH scale. Everything you need a pH scale. How the pH scale is, how the plants and animals, human life, not only human life, plants and animals are sensitive about this. Plants and animals are sensitive about this pH. See, it's a pH in plants and animals, tooth decay and soil. pH, the living organisms will live on a narrow pH level. If the pH level is less than 5.6 in the rain, 5.6 in the rain, what happens? It is called as an acid rain. It is called as an acid rain. It will damage a lot. Not only that, pH value in your body also you need to maintain properly. To only it is under a narrow pH value, it balances. If it is more or less, it will be a problem. Like tooth decay. In our mouth, if pH value is less than 5.5, then your teeth will get corroded. Why the pH value will change means the food what you eat, the bases and the acids of pH value measures. The food, the more acids, more cakes, more chocolates and acidic, all you will eat it, then you will get, your teeth get corroded. It becomes what? Less than 5.5. The teeth is made up of calcium phosphate. So if you eat more pH level food, you will get damage with your teeth. And next is soil. In the soil also it is very, very important. To test the pH value of a soil, you need to take in a test tube soil. In a test tube soil you need to take and water into it, and you put pH scale in that. You put pH scale in that. If it is acid, then the crops may get damaged. It will the fertilization will get reduced by, and if it is a base, also it is not suitable for some crops. So it will be neutralized, not acidic nor base. So what you need to do, you are not for the soils. If you add more and more artificial fertilizers in that, it may get damaged and the land may become with more pH acidic nature of the land will become more, so that with that some crops will not grow. So the acid, it should be not more pH or less pH, it should be in fertilization. Acid base is completed, is it?